All right, welcome back to your favorite Fundamentals College Math class. We're going to look at our final measure of variability, which are quartiles. The standard deviation was the average deviation for the mean. The quartiles are spread around the median, okay? And so I'll show you how to do that. And so to find your quartiles, we're going to order the data, number one. We're going to find the median, number two. And then that'll divide it in half. And we're going to find the median of the first half of data. That'll be our quartile 1. And the data of the upper half will be our quartile 3. And we'll also put our min and max on there. It's probably best to just show you an example here. So suppose we measure 9 females and their heights. Here's the data set. Number 1, let's order it. And so we got 59's our smallest, and we got 60, 62, 64, 66, 67, 69, 70, and 72. So the median, notice there's an odd amount of data, right? So if I go first and last, first and last, first and last, first and last. Okay, 66 is our median. All right, I'm going to erase all that. Okay, 66 is our median. Okay. And then how we find our quartile 1. And I'm going to go ahead and put this on a box plot right now, too. So in our 5-number summary, boy, that's a really bad box plot. We have our minimum scores of 59. Our maximum score is 72. This is going to give us our 5-number summary. Our median right there is that 66. This is quartile 2. Okay. So now what we're looking for is the first quartile and the third quartile, those numbers. Well, since we've split it into 2 halves, what we have on the bottom half is 59, 60, 62, and 64. I'm just looking at this data now for quartile 1. 59, 60, 62, and 64. Okay? And so what we're going to do is we're going to find that median of those. So first and last, it looks like there's 2 in the middle. So the quartile 1 would be their average. 60 plus 62 divided by 2 is 122 divided by 2, 61. So that 61 goes right there. That's our first quartile. Now I'm going to look at the upper quartile. Notice I'm not including that median there that was X'd out because it was right on the number. So quartile 3. So I've got 67, 69, 70, 72. I find the median of the upper half of data. Cross out, cross out. I got 2 numbers in the middle. So the third quartile, 69 plus 70 divided by 2, which is 69.5. So there's my 5-number summary. 59, 61, 66, 69.5, and 72. Again, this is my min, this is my max, this is my median, or the second quartile. This is the first quartile, this is the third quartile of the data. Well, let's say this time, instead of an odd amount of data, let's say we have an even amount of data. We have 8 females and their heights. All right, so still I want to order it. So I got 59, I got 60, 62, 64. Looks like it's in order. 66, 67, 69, and 70. Let's find the middle or median. And we know our minimum is 59. We know our maximum here is 70. Let's find our median. Cross them out in pairs. Bottom, top. Okay, it looks like I got 2 in the middle. All right, so my median is 64 plus 66 divided by 2. That gives me 65. 65 is right between those. So I put that 65, put a bar right there. It does split that into a lower half and an upper half, but it's not crossing out a number. It's not right on a number, right? But that's my median is 65. That's my quartile 2. So the lower half is 59, 60, 62, and 64. So I find the median of the lower half. Cross out bottom top. Looks like there's 2 in the middle. So quartile 1 is 60 plus 62 divided by 2, which is 61. 61 is quartile 1. My upper half of data, so up here, 66, 67, 69, and 70. Cross out bottom top. It looks like there's 2 in the middle, so my third quartile is their average since there's 2 in the middle. So I got 68. 68 inches is the third quartile. And there's my 5-number summary, 59, 61, 65, 68, and 70 based on those measurements. Now I actually already introduced this box plot. That's just the visual representation of that 5-number summary. Just try to be accurate, with it, and try to use consistent intervals so it's as accurate as possible. Notice I gave the intervals here of 1, right, for heights in inches. So let's do it for this one. Let's see, it was 50. Let's see, it was 59, 61, 60. Oh, I'm sorry. It gives me the 5-number summary right here. So it's already given us the minimum right here, 59. Maximum 72. I think this is from our first set of data with the 9. Yeah, we have 9 female data. So our first example there. 66 is our median. There's quartile 2. 62 is quartile 1. That's quartile 1. 69 is quartile 3 from the 5-number summary. So I'm going to connect those, and you can kind of see there's our it shows a little bit of that variability using the 5-number summary, right? And sometimes you'll also see when they create the box plots, sometimes they'll make that a bar like that as well for the min and the max. You'll see both of those just depending on your textbook. Now let's look and analyze this here. It says box plot below is based on the birth weights of infants with severe idiopathic respiratory distress, so SIDS. Box plot separated show the birth weights of infants who survived, the top one, and on the bottom, the birth weights of those that did not survive. Okay. So if I'm comparing the two, right, just looking at the 5-number summaries that are displayed visually, the box plot reveals the birth weights of the infants that died appear to be overall smaller. See how these, are like smaller on the graph, right? This and below kind of deal than up here, right? In other words, 50% of these are like 1 point something. Maybe that's 1.6 and below, like 50% of them. 75% of them are like 2 point, let's say that's 2.2 and below. Well, that's at the median. 50% are 2.2 and below those that survived, right? And so, again, we can see the median birth weight of the infants that survive is the same as the third quartile of the infants that pass away from SIDS, right? So that's kind of how you want to, think about that or analyze that, is think about your quartiles on those. Next question below on percentiles. What percentage of the values in a data set lie at or below the 30th percentile? Well, if you're in the 30th percentile, then 30% of the data values lie at or below that's what the 30th percentile means. 30th percentile. Part B. What percentage of the data of the values in a data set lie at or below at or above the 30th percentile? Well, if 30% are below, then and 100% of the data is there, then 100 minus 30%, 70%. Or maybe you want to think about in terms of the box plot, right? Yeah, right here is the 25th percentile. So the 30th percentile is right here, about. So there's the other 70% up there, right? So 70% lie at or above the 30th percentile. Okay, part C. If there are 500 measurements taken, right? So we have 500 data values. How many? It's kind of like saying if you have 500 test takers, then how many are at or below the 30th percentile? Well, if there's 500 test takers, what's 30% of that? So times it by 30%. So there's 150 test takers or values that lie below the 30th percentile, BELOW. Well, 500 measurements were taken. How many would be above it? Well, we know there's 70% above it, right? So there's 500 test takers. How many are above it? 350 test takers. Values lie above the 30th percentile. Now, on this last example, I'm just going to show you how to use Google Sheets to find the summary, 5-number summary for those. Let's do it with the 9 data values for the female heights here. I do want you to note right here, there are a couple different ways to calculate quartile that are correct. In some cases, it can include the median. Other cases, it excludes. We're going to be excluding the median. Okay, so you got to make sure you enter it correctly for the quartile. So there's my instructions on this. We're going to enter the data values, and then we're going to put in equal quartile, and then for quartile 1, equal quartile.exe. That again is meaning excluded on that. I'll show you what I mean. Let me open up Google Sheets. So if you have Google open up a new Google Sheet. Let's go ahead and enter our data. It was 67. It was 59. It was 66. It was 72. It's 60, 70, 62, 64, and 69. Okay, there's all my data. Let's go ahead and find our mean first, just for good practice. So our mean equals average A1 to A9. There's our mean. Right? Now, I'll put over here formula text E1. That shows you the formula there. Let's do our mean, median, and we'll do our standard deviations as well. Equals median A1 to A9. Let me show you my formula again. Let's do our standard deviation of a sample. So dividing by, I think it was n-1 if I remember right. So equals STDEV A1 to A9. Now let's do standard deviation population equals STDEV P A1 to A9. And there's my formula. All right, now let's finally do our 5-number summary. 5-number summary. The first one we want is our minimum. I know that's kind of easy to see, but if you're not sure, you just say equal, find your quartile of those A1 to A9 data, but it's quartile 0, so you put a comma 0 on that. Comma 0. You know what? Let me equals formula text E7. You know what? Let me blow this up. Let me see here. There we go. Sorry about that. I should have did that earlier. There we go. All right, there's our minimum. Now we're going to do, let's do quartile 1. So I go equal quartile dot exc. I got to exclude median if I have to exclude the median based on number of data values. A1 to A9. This is quartile 1, so comma 1. Oops, let me equal formula E8. There's our formula. Let's do our median, also known as quartile 2, equal quartile dot exc A1 to A9 quartile 2. Enter. Oops. Let's do quartile 3 equals quartile dot exc A1 to A9 comma 3. And by the way, oops. Just note that on the second quartile, it actually doesn't matter if you exclude or not. It'll still give you the median regardless. But quartile 1 and 3, I got to have that .exc on that or I'll mess that up for me. Okay. Finally, our maximum, or quartile 5, equals quartile A1 to A9. It's the 4th quartile, or the maximum. And there it is. That's how you get your 5-number summary: 59, 61, 66, 69.5, and 72. I hope that helped. Thanks so much for taking notes. See you next time.